So welcome to VG Lectures. And now we are going to discuss the topic magnetostatics. As you know, when a charge is at rest, it produces a field around it, which is called electrostatic field or simply electric field. And when a charge is moving with a uniform velocity v, then it produces a static current. This charge produces this uniformly moving charge produces a static current. It is called a static current, and it produces a field around it, and it is called magnetic field. So coming to the ideas of magnetostatics. As in electrostatics, here also we are dealing with some basic laws of magnetism. Here first one is the Biot-Savart law. So the Biot-Savart law gives the expression for the magnetic field produced by a current carrying wire. Here we are considering current carrying wire of carrying a current I, and we are going to find the magnetic field at a point here, that's at a distance r from the point from a point here. So first we are going to find an magnetic field dB, which is a small magnetic field produced by a small current element, this element. So this is a this length we can written as dl. So what is the current element here? This current element can be written as idl. Current element can be written as idl. So the magnetic field produced dB, the small magnetic field dB, will be always proportional to this current element idl, and also it is proportional to the angle theta, this angle theta. So not directly to theta, it is proportional to sine of the angle, so sine theta, and also it is inversely proportional to the distance 1 by r square. So combining these three relations, we are writing dB will be proportional to I dl, then sine theta, then divided by r square. So removing the proportionality by adding a constant, so it will be equal to dB equal to, that constant can be found as mu 0 by 4 pi. So mu 0 by 4 pi I dl sine theta divided by r square. It can also be written as mu 0 by 4 pi I dl sin theta. dl sin theta can be written as dl cross r cap divided by r square. dl cross r cap divided by r square, and we need to find the total magnetic field B. So the total magnetic field B will be equal to just the integral of dB. Okay, integral of dB. It can be written as mu 0 by 4 pi, then integral I dl cross r cap divided by r square. Also it can be written as mu 0 divided by 4 pi integral I dl. This unit vector can be written as, we are adding just a magnitude r also here. So we are multiplying and dividing by this magnitude r. So here it will be r into r cap will be equal to vector r. R into r cap will be vector r. So dl cross vector r divided by r into r square will be r cube. So this is the magnetic field expression. So this is called the Biot-Savart law. Okay, this is an expression for finding a magnetic field at a distance r from this point where it makes an angle theta with this current carrying wire of current I. Okay, so it is B is equal to mu 0 by 4 pi integral I dl cross r cap divided by r cube. This is called Biot-Savart law. Coming to the applications of Biot-Savart law, first we are considering linear currents. So consider a straight current carrying conductor of which carrying a current I, and we need to find the magnetic field at a point P. P makes an angle theta 1 with this end and theta 2 with this end, as it is not at the center of this straight current carrying conductor. Okay, this point is not from the center, this another one side you can see. You're just taking this portion here, this is a distance A, and which makes an angle theta. Just consider this as theta here, and this distance as L. Okay, so here you can find some terms, that is sine theta will be equal to, and this angle can be taken as, this distance can be taken as r. We don't know how much this is, this just take it as r. So sine theta will be equal to, sine theta is opposite side by hypotenuse, so a divided by r. Therefore r will be equal to a divided by sine theta, or a cosec theta. 1 by sine theta is cosec theta. Okay. Next, we are considering tan theta. What is tan theta? Tan theta is equal to opposite side by adjacent side. That is A divided by L. From here, L is equal to A divided by tan theta, which is equal to A cot theta. Okay, A cot theta. So just taking a derivative with respect to theta, that is dl by d theta will be equal to A into derivative of cot theta will be minus cosec square theta, minus cosec square theta, or dl is equal to minus A cosec square theta d theta. Just need to remember this equation and this r, that equation. So here from the Biot-Savart law we know that dB equal to, this is expression from Biot-Savart law, mu 0 divided by 4 pi I dl sine theta divided by r square. This is the expression from Biot-Savart law. Okay, so this is a small magnetic field due to a current element IDL. So which is equal to mu 0 divided by 4 pi into I dl. This dl can be written as minus A cosec square theta d theta into sine theta divided by r square. What is r? R is A cosec theta. So r square is A square cosec square theta. So cosec square theta can be get cancelled here, and A square and A get cancelled. Okay, so what will be the expression? So the expression will be dB is equal to, there is a minus sign that can be taken here, minus mu 0 divided by 4 pi into I divided by A is there, then sine theta into d theta. These are the terms remaining from the previous equation. So this is the dB that we are getting. So how to find B? This is the integral of dB. Integral dB, which is equal to minus mu 0 by 4 pi, mu 0 by 4 pi into I by A. This can be taken outside. Integral sine theta d theta, which is equal to minus mu 0 by 4 pi I by A into, what is the integral of sine theta? This integral of sine theta is cos theta. Integral of sine theta is minus cos theta. Integral of sine theta is minus cos theta. So this minus, and here also one more minus will come. So it will be plus only. So cos theta from limit, from where to where we have to take. That is here from the previous figure, you can see that theta 1 is taking from this point. This is a theta 1 that we are taking, and this is a theta 2 that we are taking. So theta 1 is taking in this direction, and theta 2 is taking in this direction. So we cannot integrate from theta 1 to theta 2. We have to take the angles in same direction. So this is theta 1 that we are taking in this direction. So here also we need to take the angle in this direction. So this is theta 1. So this can be the taken as theta 1, and up to where? Up to this angle that we have to take. This angle means this is total is pi minus theta 2. So this angle can be written as pi minus theta 2, which is equal to mu 0 by 4 pi I by a into cos of pi minus theta 2 minus cos theta 1, which is equal to mu 0 by 4 pi I by a cos pi minus theta 2 will be minus cos theta 2. So this is minus cos theta 2 minus cos theta 1. Okay, so this can be written as minus can be taken outside, that is minus mu 0 I divided by 4 pi a into cos theta 1 plus cos theta 2. So this is the final expression, and the magnitude once again we can written as magnitude of b. Magnitude of b is equal to mu 0 I by 4 pi a, mu 0 I by 4 pi a into cos theta 1 plus cos theta 2. This is the expression you have to remember for finding the magnetic field of certain straight current carrying conductors. We have to see the examples. So generally, here we are taking a distance r from this current carrying conductor. We are finding a magnetic field here. So we got the expression for that, that is B is equal to mu 0 I by 4 pi r into cos theta 1 plus cos theta 2. This is the expression that we are getting from Biot-Savart law. And again, the same condition that we are considering here, r is the distance and this is theta 1, this is theta 2, and I is the current passing through here. And here we are considering two more angles, that is this alpha and this is beta. Here we have taken the angles from this end points. So here we are taking from this point. Here we are going to find the magnetic field. So from here at a distance r, the straight conductor is placed. So the angle alpha and beta here we are considering. So we need to find the magnetic field in terms of this alpha and beta. So how we will find this? From this triangle, alpha or theta 1 will be equal to, or theta 1 plus alpha plus this 90 will be equal to total 180, or theta 1 plus alpha will be equal to 90 degree, or simply theta 1 is equal to 90 minus alpha. Similarly, theta 2 is equal to 90 minus beta. Here also this is a triangle, so 90 minus beta. Substituting these these two things here, b is equal to mu 0 I divided by 4 pi r into cos theta 1. Theta 1 is 90 minus alpha plus cos 90 minus beta. So what is 90 minus theta? 90 minus theta is nothing but cos 90 minus theta is nothing but sin theta. So mu 0 I divided by 4 pi r into sin alpha plus sin beta. So this is the expression that we are using for finding the solving some problems. So this things you have to remember, that is alpha. What is alpha here? This angle, and beta is this angle. Okay. So we are considering a long straight wire which carrying a current I. It is an infinite wire at both ends. That is, here this end is also infinite and here this end is also infinite. When both ends are both the ends are infinite, this angle may be 90 degree. That is this angle, alpha and beta. We have to find alpha and beta. If this is the point at which we need to find the magnetic field, and it is at a distance r. We are just taking an angle alpha here and beta here. So if it is extending to infinity, this alpha and beta, this alpha, the angle alpha will be 90 degree, and also the beta will be
90 degree. If alpha and beta are 90 degree, so we know the equation is B is equal to mu 0 I by 4 pi r into sine alpha plus sine beta. Both the angles sine alpha and sine beta. If alpha and beta are 90 degree, sine 90 plus sine 90 will become, which is equal to mu 0 I by 4 pi r into, what is sine 90? Sine 90 is 1 plus, again sine 90 is 1, which will be equal to mu 0 I by 4 pi r into 2. That is mu 0 I by 2 pi r. So this is the expression of magnetic field when both the ends of the wire are infinite. Next, we are considering only one end as infinite, and we are finding this is the wire which carrying current I, and this is point where we are going to find the magnetic field, and it is at a distance r from one end, so there is no angle on this end. On the other side, listen, as we know, on this side the beta will be equal to 90 degree, and there is no alpha, or alpha is equal to 0 degree, as it is right angle at this end. Alpha will be equal to, alpha is angle here, so alpha will be equal to 90 degree, and as we know, beta equal to, alpha equal to 0 degree and beta equal to 90 degree. Again we are substituting the same equation. B is equal to mu 0 I by 4 pi r into sine alpha plus sine beta is equal to mu 0 I by 4 pi r into, what is sine alpha? Sine 0 equal to 0 plus sine beta, sine 90 equal to 1. So it is equal to mu 0 I by 4 pi r. Okay, this expression when the magnetic field, expression for magnetic field when one end of the straight current carrying conductor is infinite. Okay, so coming to the next problem, that is, it is a finite wire. It is not infinite. It is a finite wire of total length L. Here we are going to find a magnetic field here. This is at a point R from the center of this straight current carrying wire. So this length is L by 2 and this length is L by 2. When we are plotting like this, here we are having an angle alpha, and also here we are having an angle beta. So we know the expression B is equal to mu 0 I by 4 pi r into sine alpha plus sine beta, sine alpha plus sine beta. Okay, so let us find the value of sine alpha as well as sine beta. What is sine alpha here? Sine alpha equal to, as this angle is theta, sine alpha equal to opposite side by hypotenuse. Opposite side by hypotenuse. Okay, so we don't know how much the hypotenuse, and we know this this is the arc length, this is L by 2. So what will be the hypotenuse here? It will be equal to r square plus L by 2 square. L by 2 square means L square by 4. So here also the same expression, r square plus L square divided by 4. So sine alpha will be equal to opposite side. What is opposite side? L by 2 divided by hypotenuse, which is equal to square root of r square plus L square by 4. This is the expression. Also sine beta. Sine beta is also same quantity because this is beta, opposite side divided by hypotenuse will be the same. So which is equal to L by 2 divided by square root of r square plus L square by 4. Okay, let's substitute in this expression, that is B is equal to mu 0 I by 4 pi r into 2 times of this expression. Okay, so 2 times sine alpha plus sine beta, as both the quantities are same, 2 times of this quantity, 2 times L by 2 divided by square root of r square plus L square by 4. Okay, so this 2 and 2 gets cancelled, which is equal to mu 0 I by 4 pi r into L divided by, this can be cross multiply here, so 4 r square plus L square divided by 4 will come. It is, we will write like that only, square root of 4 r square plus L square divided by 4. This 4 is also inside the bracket. So it will be equal to root of 4 will be 2, as it is in denominator of this denominator it will become as numerator 2. So mu 0 I by 4 pi r into 2l divided by square root of 4 r square plus L square.